Somewhere in the dark, a dead world is pulsing, a steady signal no one can explain. And by the laws of physics, this planet should not even exist. The star died long ago. It swelled into a red giant, then collapsed into a white dwarf, a cooling ember barely wider than the Earth. Anything orbiting close should have been swallowed whole when the star ballooned outward. Yet one planet remained, silent and intact. We call it KMT 2020-0414b, a rocky world nearly twice the mass of Earth, circling a stellar graveyard. It hangs about 2 astronomical units out, twice the distance Earth sits from our sun, frozen in the faint glow of a dying cinder. For years, it drew no attention. A cold rock around a dead star is not, on its own, remarkable, until the listening began. Because in the reconstruction of this system's light, researchers noticed something that did not belong: a faint, repeating rhythm. Not the random static of space. A pulse, evenly spaced, patient, as if the frozen world were quietly keeping time. It should be impossible. There is no warm star to power it, no obvious engine, no reason for a dead system to hum. And so a question forms, the kind that keeps astronomers awake. Is this the physics of a corpse, or something reaching out? To answer it, we have to go back to how a planet this improbable was ever found across 4,000 light-years of darkness. This is the story of a survivor, a graveyard, and a signal we cannot yet explain. You cannot photograph a planet this far away. It is too small, too dark, lost in the glare of the galaxy's crowded core. Instead, astronomers wait for a trick of gravity, an alignment so precise it may happen for a given star just once in a lifetime. It is called microlensing. When one star drifts exactly in front of another, its gravity bends and focuses the distant starlight. For a few days, the background star flares brighter, here magnified more than 1,000 times, as if a lens had swung into place. The Korea Microlensing Telescope Network caught it in 2020, logging the event as KMT 2020-0414. 3 telescopes, spread across 3 continents, watched the same patch of sky so the flare could never slip below the horizon. And inside that smooth rise and fall of light hid a smaller flicker, the fingerprint of a planet tugging on the beam. The lens star sat about 4,000 light-years away. The star it magnified was more than 5 times farther, near 25,000. From that brief flash, astronomers reconstructed an entire hidden system: masses, distances, orbits, from light that lasted only days. The host was not a normal star at all. It was a white dwarf, roughly half the mass of our sun, and long since dead. Beside the planet, they found a third body, a brown dwarf, some 17 times the mass of Jupiter, a star that never ignited. A dead star, a failed star, and a frozen survivor, bound together in the dark, revealed by a single fleeting alignment. To understand the survivor, you have to watch its star die, a death our own sun is slowly, quietly rehearsing. Billions of years ago, this was an ordinary star, much like the sun, fusing hydrogen in a steady, patient glow. But every such star runs out of fuel. When the core's hydrogen is gone, the balance holding it together begins to fail. The core contracts and heats. The outer layers swell outward, and the star bloats into a red giant, swallowing its inner worlds. Had Earth orbited this star, it would likely have been dragged into the fire, vaporized as the giant's surface expanded past it. The survivor should have shared that fate. At its original orbit, the growing star's edge may have reached terribly close. But a dying star does not only expand, it bleeds. It sheds its outer layers into space, losing a huge fraction of its mass. And as the star grows lighter, its gravitational grip loosens, so every surviving planet drifts gently outward into a wider orbit. That is likely how this world escaped. As the star shrank in mass, its orbit expanded faster than the fire could chase it. When the red giant finally collapsed, it left behind a white dwarf, dense, dim, and cooling toward eternal dark. The planet settled into a new path, about 2.1 astronomical units out, circling an ember where a star used to blaze. It had outlived its own sun, and in doing so, it became a preview of a future our own planet may one day face. Picture the survivor now, a rocky world, nearly twice Earth's mass, wrapped in a silence that has lasted billions of years. Its sky holds no warm sun, only a white-hot pinpoint, blindingly small, giving light but almost no heat at all. The surface is frozen far below anything Earth has known, a landscape of ice and rock lit in pale, colorless day. Somewhere out in the dark drifts the brown dwarf, a dim, failed star, glowing faintly with the last of its birth heat. There are no seasons here in any sense we would recognize, only the slow, endless circling of a grave. This is what waits at the end of a solar system. Not fire, but cold. Not chaos, but a still, frozen order. And it is precisely that stillness that makes the signal so strange. Dead worlds are supposed to stay quiet. A frozen rock around a dead star has no obvious way to broadcast anything. No warmth, no weather, no restless churning core. So when a rhythm rises out of that silence, every instinct says, check your instruments first, and then check them again. The signal, if it is real, is faint, a whisper of electromagnetic energy, rising and falling in a steady, deliberate beat. The first task is to rule ourselves out. Satellites, ground stations, the hum of our own machines that so often masquerade as discovery. Then the natural suspects. Could a spinning magnetized body nearby be sweeping a beam across us, like a lighthouse in the dark? White dwarfs can carry fierce magnetic fields. Paired with a brown dwarf, they can, in principle, generate pulses of radio light. That would make this a geological echo. Dramatic, but natural. Physics, not intention. The universe keeping its own strange time. But the architecture of the wave matters. Natural pulses tend to drift, to smear, to carry the fingerprints of a chaotic source. A truly clean rhythm, too regular, too narrow, too rich with structure, is far harder to explain and harder to dismiss. So we reconstruct the wave against the backdrop of the star's collapse, asking a single question: does this pattern carry meaning? Geological echo, or intentional beacon. Between those two answers lies one of the widest gulfs in all of science. Whatever the signal proves to be, this world already carries a message meant for us, one written in orbits, not in code. In roughly 8 billion years, our own sun will swell, redden, and die, retracing the very death this system has already survived. If Earth is not swallowed, it too may drift outward and endure, a frozen relic circling the white ember of the sun. This planet is that future, seen early, proof that worlds can outlast their stars and keep turning long after the light goes out. The signal may yet resolve into simple physics, a dead star talking to itself in the language of magnetism and time. Or it may not, and until we know, a frozen survivor keeps its steady rhythm, 4,000 light-years away, in the dark.